Welcome. This video is going to take a closer look at formulas and how they relate to ionic compounds. There's two kinds of chemical formulas. Molecular formulas like H2O represent molecules which have to have covalent bonds. That's the very definition of a molecule, is it's something held together with covalent bonds. So ionic compounds technically aren't molecules. Remember, they form crystal lattices, and so you have these repeating structures like the two pictures below show. So really, instead of writing a molecular formula, you write a formula unit, okay? Both chemical formulas are going to show the ratio of different elements needed so that the octet rule is obeyed for all the atoms. But with the crystal lattice, because it could be as big or small a crystal as you want, you write the simplest ratio for it, and that's what we consider the ionic formula or the formula unit for an ionic compound. So formula units have a couple rules to them. The total charge for an ionic compound must equal 0, and the reason for that is because the electrons gained by one element has to be equal to the electrons lost by another element. Remember, an element's not going to lose electrons unless there's another atom actually pulling those electrons off, so they have to go somewhere. So total charge will always be 0, and since the ions form a crystal lattice, and this crystal lattice could go on forever, the formula unit then is the smallest ratio of the cation to anion in the crystal lattice. And the cation is always given first, and the anion is listed second. And I just remember that because when you look at the periodic table, the metals are on the left side, the nonmetals on the right side. So the metals form the cations, the nonmetals form the anions. So it's just like reading. You go from left to right. The way they show up on the table from left to right is the way they appear in formulas. So we did a little bit of this in the last section, but to determine the formula unit, you really need to know a couple things. You need to know each atom's oxidation number, and then you need to figure out the number of ions each atom would need to form so that the electrons lost is equal to the electrons gained. So what's oxidation number? Oxidation number is the number of electrons an atom needs to gain or lose to have 8 electrons in its outer shell. So to be obeying that octet rule. So you can easily determine an element's oxidation number by what family it is on the periodic table. And I just happen to have a periodic table here. And I've written in the oxidation numbers for families 1A through 8A, which are the easy ones, as well as the transition elements, even though several of them are missing in the middle of our chart here. But remember, for the metals in families 1, 2, 3, and 4A, that's going to be the oxidation number with a positive charge because those metals are going to lose 1, 2, 3, and 4 electrons to become stable. But then starting with family 4, with the nonmetals, which is where the first true nonmetals appears in family 4, then you look at the group number and subtract it from 8 to determine how many electrons each of those will gain. So group 4 will gain 4 and pick up a -4 charge. 8 minus 5 means group 5 will have a -3, group 6 -2, group 7 -1, and again, no surprise that the noble gases over in group 8A will pick up 0 charge because they don't need anything. Transition metals, as I've indicated, technically have 2 valence electrons, but because they're filling up the d orbital and not filling up the outer p or s shell, they can actually move or transfer electrons around. So if they don't give you a Roman numeral, you can assume it's 2. Otherwise, they'll give you the oxidation number in Roman numerals, and it's always positive because these are metals. So I'm going to have you go ahead and try a few here. Find your periodic table. If you want to pause and try each of these, remember the way I do it is to either draw boxes showing the electrons being lost as plus signs and electrons being gained as minus signs, or you can do a little mathematical table where you're looking for the least common multiple and determining how many of each ion you would need to reach that least common multiple. So if you want to pause and try it yourself, that would be great. Otherwise, I'm going to go ahead and start working through my solutions. So determine the correct formula for the following chemical reactions. If I have sodium, I find sodium in group 1A. So I know it's going to lose that 1 electron and pick up a +1 charge. I find chlorine over in group 7A. So 8 minus 7 means it's going to gain 1 electron. And so Na has 1 electron to give. Chlorine is able to take 1 electron. Then I see that I just need a 1-to-1 ratio, or my formula would be NaCl. Looking at the second one, now if sodium combines with oxygen, sodium still picks up a +1 charge as it loses its 1 valence electron. So I'll show it with my box. Now oxygen in group 6A needs to gain 2. So when I draw oxygen, I need 2 electrons, which obviously 1 sodium is not going to give me 2 electrons. So I'm going to have another sodium atom, or a 2-to-1 ratio, and I would write the formula Na2O. Here's a couple more to try. Magnesium is in family 2A and will pick up a +2 charge. Oxygen, still in family 6A, picking up the -2 charge. So now I have magnesium with 2 electrons to give. I have oxygen, which needs to gain 2 electrons. And I see that electrons lost and electron gained will be equal with just 1 of each, or MgO. And the last one, aluminum. This is in family 3A, but it's still a metal, so it's going to lose its 3 electrons. Oxygen still needs to gain 2 electrons, and this is really as complicated as it gets, is when you have one atom needing to gain or lose 3, and the other one needing the 2. So when I start out with 1 of each, the 1 oxygen is satisfied, but the aluminum is not, so I need to bring in another oxygen. Well, that helps the aluminum, but now the oxygen is out of balance. It's short an electron. So I bring in another aluminum. And just when it looks like this is never going to work out, it actually does. And again, if you think about least common multiples, the least common multiple of 3 and 2 would be 6 electrons going to have to be lost and 6 electrons gained, which means you'll need 2 aluminum to donate 6 electrons and 3 oxygen to take those 6 electrons.